Hey there, do you have any questions?
Oh, hello. Yeah, I have a question.
Sure.
So the exam that's tomorrow, it's going to be covering the first two chapters, well, the first uh lessons 7 and 8, the expansion kinetic theory of gases. Is that correct?
Yes. Yeah, it's going to be the very first two chapters in the thermal unit.
All right. And I was wondering if I could know which problem specifically I lost points on the last exam.
Um, all right. Let me see. Give me a second. All right. So I looked at it, and it seems that you got 6 points on question one and 9 points on question two. So most of the points were coming from question one.
All right. I'll be sure to look over that.
Okay.
And last question was so on Edpuzzle, I had missed a few days, but I'd used the YouTube videos to catch up on those. Should I still go back on the Edpuzzle and just like go through those videos regardless?
I think as long as you answer the questions, that's enough for me to be able to put in that attendance purposes. I don't need it to say that you completed watching the video.
Oh, okay. So I should go and put the questions in.
Yeah,
All right.
and like I said, it's really only for attendance purposes.
Yeah, okay. All right, that's all I wanted to ask. Thank you.
All right, no problem.
Have a good day.
You too. Bye. Hey, how's it going?
Hey, would you be able to go over the second test? Like, can you tell me what I got wrong or like, I'm not sure.
All right, let me quickly check.
Yeah.
Um, all right,
Are you
so
are you gonna
most
post the answer key or?
No,
Okay.
I don't post the answer key for that. So for you, you only really lost 1 point on question two, in particular, the last part. Um, question one is where you lost most of your points.
Okay.
So let me try and see.
You said that each question is 10 points, right?
Yeah,
And then out of the 20 points, you just like multiply by 5 to get my grade.
well, it got curved.
Oh,
So
okay. Oh, okay. Okay.
yeah. All right. So for the question, so question one, I'm trying to remember what they were specifically. Um, Let me actually. That's the question with the pipe. No, that was question
So
two.
springs.
Right. Okay. So I don't really know exactly why you end up losing a point. But the
Okay.
main thing was you end up having a platform that looks something like this, and you had springs connected on top of each other. This is essentially a series setup. So to
Yeah.
find the actual spring constant, you had to do an inverse sum of all the numbers.
Mhm. That's what I did, right?
Maybe. I don't know. I don't have your thing
Oh,
on hand
okay.
right now. All I know is that you lost a point on here. Uh, so this can actually be reworked, and you could have realized that since they all have the same value, that the total spring constant is really just a fourth of the whatever their individual spring constant is. Once you do that, it then asks for angular frequency. And I know, so the two issues that people had with this equation were either using this number incorrectly
Mhm.
or are at k over m. Some people also put in the wrong mass because you're supposed to use the entire mass of the system. Uh, but the other issue that people had that I saw was that some people weren't solving for angular frequency, they solved for regular frequency.
Got it. I mean, I did 2 pi frequency. Was that? I said angular
Yeah,
frequency is equal to
yeah,
2 pi
that's still
f.
fine.
yeah. And then for the series for find spring constant, I did 4 times 1/k since they're all the same. Is that not right?
Did you make sure to flip it? Actually,
Yeah,
what did you put in for frequency? What's the equation they use?
I did 1/2 pi times the square root of k over m.
I think that's the issue.
Yeah,
Wait,
that's the frequency equation, right? And
oh,
then
K over M. Okay,
after that, I multiplied by 2 pi to get the angular frequency.
okay.
Uh,
You might want to just double check your math with some of those numbers because um,
do you know the right answer to that?
it was like 4.5 or something.
4.5. Oh, I got 1.378.
Yeah. So something went wrong with your calculations. I don't have it on hand right this second.
Wait, do you want me to share my screen or is that like
You
I
can
can do
show it.
that? Yeah.
Yeah, it's fine.
Um. Can you see my screen?
Yes.
This is what I had.
Okay. Uh, yeah, yeah. Um, that's because you forgot to flip your spring constant value. Also, I think your mass is. I think you converted your mass weird.
I converted into kilograms, right?
Yeah, but it should have already been in kilograms.
Pretty sure it was in grams. Really? I thought it was in. I swear it was in grams. I don't know.
Fortunately, I don't have the question in front of me either.
Okay.
Uh, let's see if
So for the
yeah.
spring constant, it's just 170. I thought the equation was.
Hmm.
Isn't that the equation I wrote there? Is that wrong?
No, that equation's right, but notice how on the left-hand side it says 1 over k equals 0.0085. So we
Oh,
want k, so you have to. That's why you have to flip it at the end.
okay. So just 117.
Hmm.
Got it. But the rest is looks good.
Yeah, like the equations that you used were right. It was just that part. All right.
So I lost 1 point for that.
Yeah, it was only 2 points.
Oh, okay.
In fact, I think almost a lot of the stuff on here was 2 points, except for
Mm-hmm.
C. C, I think was 3 points. Wait,
Got it.
was it? I can't remember anymore. It was. Yeah. Okay. So one of those. I'm pretty sure C was 3 points, and I think B was also 3 points. So both of those were 3 points. All right. So the issue with part B. Um, now this was something that a lot of people end up having issues with. In fact, B, C, and D were ones that people had trouble with, and it's something that I knew people were gonna have issues with because
Uh-huh.
it's a common fallacy that a lot of people have when it comes to using energy. A lot of people just tend to simplify problems a little too much.
Yeah.
You get into this habit where you are constantly looking at one type of setup. Like in this case, a lot of people were thinking of horizontal oscillations and
Mm-hmm.
completely forgot how things changed now that we're dealing with a vertical oscillation. That while the overall form is similar, not everything is exactly the same. In addition, another issue that people have is they think that they can always use the idea of energy being conserved, energy before equals energy after, but there's always caveats to that equation. So for part B, it kind of focused on that first issue that people have, and that's um, not taking into account all the energies. In a horizontal oscillator, actually, I should probably mention that some people try to use this equation for max speed, because if you take the position equation and take the derivative, that's what you get. The only issue is
Mhm.
that um, first, the you don't know what the amplitude is. You'd have to actually do some extra work for that. But also, that's true when the only other force acting on the object is the spring force. Like, that's the only force acting to cause this oscillations. This doesn't work for a spring that is in a vertical oscillation that's also experiencing a gravitational force.
Oh yeah.
So
Okay. Yeah.
when you do conservation of energy, what you were supposed to realize is right after the two end up striking each other, it has kinetic energy, and then as it goes up, it has spring potential plus gravitational potential energy.
Got it. Okay.
So that was the big issue. A lot of people forgot to include the gravitational part.
Yeah.
So um, it ends up changing the numbers a bit because the gravitational potential is, I think it was fairly low relative to the spring. Uh, it wasn't like a drastic difference in value, but it definitely was noticeable. So
Mhm.
depending on how you set up your equation, you could have lost a 1 or 2 points on that.
Got it. I mean, I also used the wrong spring constant. Did I lose extra point for that, or like you
Yeah.
said
So the thing with that, I know I mentioned that I don't charge with double jeopardy,
that?
but
Yeah.
there's ways to avoid the double jeopardy, and unfortunately, there's also some ways to fall into the trap of constantly getting hit for it. Now, uh, the if you had used that angular frequency in the next part, like if you actually worked out that equation so that it was solving for angular frequency, like as a term, and then you use the 1.378 in for
Yeah.
it, then I could overlook it because it's like, okay, well, it's based off of that number he's using, but because it wasn't done that way, um, I ended up not being able to do that. Parts. So that was what you had to do for part B. Part C, like I said, the big issue here was that a lot of people just um, I don't think they were paying attention to what exactly it was asking. It was
Uh-huh.
asking not what the speed of the ball was before it hits the platform, but rather what the speed was when it was initially thrown. So you had to do essentially 2 parts. First thing you had to do was use conservation momentum in order to figure out what the speed was before the ball hit. The ball uh, collides with the platform. So you use whatever speed you got from over here, plug it into here to figure out, the whole conservation momentum. Uh,
Mhm.
Now, some people basically stop there, and I think that's what you did here.
Yeah.
And then, but what you're supposed to do is realize that that's telling us the speed right, like this speed right here, right as it's about to hit. You then had to use either,
Kinematics.
yeah, you could use kinematics, something like VF squared equals V naught squared plus
QA.
2AX,
Yeah.
or you could use conservation energy. This time you could go simple, do potential plus kinetic. Either way, there's two different ways to find what the actual initial speed is. Um,
Mhm.
Now there were some people that did do energy, but they did it right from the beginning, like right where they used the speed of the ball and platform initially after the collision, and then they tried to figure out what the initial kinetic energy was of the ball and set them equal. But you can't do that. because this is an inelastic collision, there's some energy being lost, some kinetic energy being lost. So energy isn't, I shouldn't say energy, mechanical energy, potential and kinetic are not being conserved.
Mm-hmm.
So essentially, the collision is acting as a boundary where you can do conservation energy like after the collision. You can do conservation energy before the collision, but you can't have numbers uh, bridging that gap. You can't have one side of your conservation of energy being referring to after the collision and one side referring to before the collision. So, like I said, these are two really big issues that people have. So, unfortunately, I had to ask it in order to show or identify which people truly understood the idea of, like, whether or not you can do a certain thing with energy and momentum and stuff.
Yeah, I got it. Yeah, that makes sense.
Uh,
What about for the last part?
All right, so
That's
yeah, the last part was also a really tricky one. So you actually do have the right equation. You are supposed to use that tan function. So you're
mm-hmm.
supposed to do tan theta, or at least one of these equations. There's a few of them you can work with. The only issue is that it's important to note that right now, when the platform is by itself, so it's just resting there, it is actually at a location that's going to be slightly higher than when the clay hits into the platform. So this is X, not the initial position. This is the equilibrium position. And then after it hits, it's going to go up to some point. I know my drawing's a little bit bad.
Wait,
Uh,
why is the spring without the clay not the equilibrium position?
well, because so remember, the equilibrium position is the part where it would sit if all the energy is removed, right? Like if I stop the motion, brought it to rest, and then let go, that's where it's going to sit, right? But
Yeah.
because I've now added mass to the system, it's going to cause the equilibrium position to go lower. Like every time you add mass to this platform, the springs are going to elongate, right?
Mm-hmm.
So the platform by itself is much lighter than the platform with the clay. So the clay is going to sit a little bit lower. The other part was that um, the height that I gave you, the 1.2 meters, and this is actually the reason why that's important to note. The 1.2 meters is not from the equilibrium position, but from the initial position. So if you want the actual amplitude, you're going to need to figure out what that initial position is and add the 1.2 number.
Okay, and how do you figure out the initial position? Is that the tan equation?
That's where you do the whole sum of the forces. So what's going on? All right. So when the clay's touching this, we have gravitational force pulling down. We have a spring force pulling up. These are equal and opposite, so I can use the additional mass of the clay on top. Like I don't even really need to worry about the platform, but I just figure out how much lower this spring is going to stretch with this new clay on top. How much was the clay? Like 1.5 or something, or 1.3?
Yeah, 1.3.
All right. So what you could do is do 13 equals kx, and that will be how much the spring elongates in that initial part. So if you wanted to use amplitude, you like if you want to do instead cosine uh, x naught over a, then this is something you would have to do. If you didn't want to do that, then it would have to be you would have to do this, or if you want to do like So essentially, you got a point if you attempted one of these trig functions.
Yeah.
So if you try to do the cosine, the sine, or the tangent, and you attempted to figure out what these values were, realizing that the initial and the max values were different, right? Like that
Hmm.
the object essentially wasn't starting at zero. As long as you kind of recognize that, then you got at least one of the points. And even though this was actually a question that probably should have been worth more points, it's I was actually trying to be really nice and make it worth less, despite it actually requiring more work, so that it wasn't like a big factor, if that makes sense. Like,
Yeah.
yeah, so like I said, if you realize that you could use one of these trig functions, but you weren't really sure how to use it, but you tried to use it in some way, like you did, then you get one of the 2 points. Meaning that if you got everything else right, then you got 9 of 10, which is still really good. So it's just another way of kind of trying to figure out who really, really understands this material and who, you know, just has a really good, really good understanding versus like, you know, mastery, if you will.
Hmm.
Does that make sense?
Yeah, makes sense.
All right. Is there any
But
other questions you have?
you said my second problem, it was good, or
Yeah, for the most part, the second question was good. Like I said, for a lot of people, they ended up getting points. It was just part E that was wrong.
oh yeah, you know that. Yeah, what was the answer for that? I was kind of confused on
The frequency decreased.
decrease. Wait, what? Why?
So when it's in the air, you fit, uh, you're able to fit half a wave. Oh, that's not, half a wave into this length. So that means the wavelength is going to be twice the length of this rod, not rod, tube, right?
Yeah.
When you cover one of the ends of the tube, you actually change the standing wave to be a quarter of a standing wave, meaning that the wavelength is now 4 times the length of the rod. So according to this, I'm going to call this prime. According to this, lambda prime is greater than lambda, right?
Yeah.
And because of the equation v equals f lambda, we know that frequency and wavelength are inversely proportional. So if lambda prime, the new wavelength, is greater than the old wavelength, then I can use a similar logic and say that the new frequency is less than the old frequency.
But wasn't it being dipped in water? So
It
wasn't
wasn't
the
it
velocity
wasn't
increased?
fully submerged. It What ended up happening was only one end of the tube was actually dipped into the water.
Doesn't that still have an effect on velocity or no?
No, what's going to end up happening is, I mean, it some of the wave when a wave enters or encounters a boundary, like in this case water, part of the wave gets reflected, and because of the type of surface, this being a hard surface, uh, the wave is going to just bounce back as if this is a node. So it's going to be bounce back, like I said, as if it was like a flat surface. There is a part of the wave that does transfer through, and this wave will be affected by the the density of the water, and it's going to travel at a different speed. But I don't care about uh, this wave. I care about the wave that got bounced back.
Okay, so the frequency is lower because the wavelength increases, right?
Yeah,
Is that basically what it is?
and it's
Okay.
because we're able to fit a larger wave inside this tube. Before, when it's open at both ends, the only standing wave we could form is one where there's antinodes at both ends, and each antinode, each consecutive antinode is a half a wavelength away. So the smallest, or I shouldn't say smallest, the biggest wave that we fit is half a wave. Unlike the this case though, if I have one end that's closed and one end that's open, now I'm not going to have two like parts of the wave on opposite sides. I now end up having a node at one end and an antinode at another. And those two are always going to be a quarter to three quarters of a wave apart.
Wait, but the pipe wasn't actually closed. Just because it was dipped in water, it
It
creates the
became
antinode.
closed. Yeah,
But the,
yeah.
what was
It
it?
creates it makes it so that it's now a node, and it essentially acts as if it is closed.
Oh, okay. Yes. Okay.
This is actually a very common thing that there's a lab where you can figure out the speed of sound by taking a tube, and I'm pretty sure there was a question about it, but you take a tube and you dip it in the water, and then you can actually alter the length of the tube essentially until you get a resonant sound. And what you're essentially doing is dipping it into water gives you this a hard boundary surface so that you can essentially alter the length of the tube until you can fit that specific until you match that specific length that gives you resonance. So I was it's a play on that experiment, just in the sense of instead of dipping the entire tube in, just dipping one end of the tube.
Got it. Yeah, that makes sense now.
Is there any other questions?
No, yeah, that's it for me.
All right,
Yeah, appreciate the help. Thank you.
anytime.
Yeah.
Hey, Mr. Clown.
Yeah, what's up?
Oh, so there were a few questions, in homework. This is homework 7, chapter 18, which I wasn't sure how to do.
Okay, so let me go and open up the homework.
Okay.
All right. Do you by any chance know the page? I
Give
know
me
it's
a give me a minute. Let me see.
okay. I know it's in the around the 500s. I didn't know if you could.
Yeah, around 513.
Okay. So which page? I mean, sorry, which question?
One is number 38.
Okay. So
Oh, sorry. Wait, 32, 32. I said that wrong by accident.
all right. Okay. Um, so this entire section is basically related to the vapor pressures aspect. So what you have to do is figure out what the let me actually see. So it gives us the pressure. Yeah, so you're gonna have to figure out what the pressure is from that one table that you're given. So let me try and go back to figure out what where that table is.
Uh,
So I think it's not 505. Oh, here it
give
goes.
me.
Table 18-2,
Yeah, I can
page
see.
504.
Yeah. I mean, I have this table printed out, so I can see it right here.
All right.
Excuse me.
Mhm.
Oh. So I can find the volume is 72 meters cube. The thing is saying 24 degrees Celsius here, which can't be directly found on the table. That's kind of tricky.
Yeah. Yeah, I think you have to try to estimate it a bit. So let me just see the question in particular again. Sorry, I have to like keep going back and forth.
Okay.
Oh wow, I wasn't even looking at the right question. No wonder why I was really confused. All right,
Oh,
so yeah, they give 24 degrees Celsius. Um, so if you look back, you have 20 and 25, right? Because it's going up by fives.
yeah.
Yeah. So one thing you could do is um, I don't know if these numbers are exactly linear, but we can kind of treat it linear over short distances or differences. So what you can do is, we know that the 24 that they're referring to is going to be probably fairly close to 25's pressure, which is 3.17. So what you could do is uh, essentially find the difference between the 25 and the 20. Like find the difference in their pressure.
Difference in do we use Tor? The
Nah, you should probably use Pascal's.
Pascal. So uh
Actually, you know what? Yeah, you might as well use Pascal's because you're gonna be having to use the ideal gas law in order to find the mass, right? Yeah.
yeah.
All right. All right. So what'd you say it was
I got 0.84 times 10 to the third power.
as the difference?
Yeah, I mean the difference in pressure in Pascal.
Okay. So what you want to do is essentially that's the difference between 5 degrees. Essentially,
Yeah.
uh, you want to essentially figure out what 4/5 of that would be.
Do you mean to use linearization in calculus?
You don't have to go that crazy. Essentially, what you're going to do is find the uh, average between each degree, right? So again, we're going to assume that it's a linear increase. So if 5 degrees results in a difference of what was it, like 840?
0.84 times. Oh yeah. I mean like yeah, 840
Yeah. So try to figure out, what would be the increase per degree then.
increase in Pascal.
Yeah. So you know, it's gonna after 5 degrees, that's to increase by 840. So how much does it increase per degree?
Yeah. Oh, yeah. By the way, Mr. Cloud, I think if you want to avoid the awkward break, I think you could just record everything and then you can download a software to kind of to like make clips so you can cut
Yeah.
out
Yeah,
breaks.
I did that. It's just really time consuming so because it actually doesn't delete all the breaks. It just cuts it, and then I have to manually go through and find the breaks. And for some reason, I don't know why, my audio is recorded much lower than everyone else's. So normally I'd be able to see like, oh, there's a straight line, that must be a break. But there's been a few times where I realized I was actually talking in some of those sections. So
Oh, I see. Yeah, so I got this rate of change for 168.
All right. So then, how many degrees would it go? How many pascals? Sorry, how many pascals would it go up by after 4 degrees?
Uh, times 4 is 672.
Okay. And then starting from how much it started with, we know what was the pascals at 20 degrees again?
Pascal at 20 is 2.33 times 10 to the third power.
Okay, so then we know how much it's going to go up by, so we can figure out what it's the essentially roughly what the pressure is at around 24 degrees.
Uh, wait,
Uh,
oh,
yeah,
sorry.
then once you have that, then you could just use the ideal gas law, figure out the either the number of molecules or the number of moles, depending on which version you like. Um, I did give both versions of ideal gas law, right? PV equals nRT and PV equals NKT.
Uh, we mean PV equals nRT?
Yeah, so there's one version of the ideal gas law, which is PV equals number of moles times the gas constant times the temperature.
Yeah,
But there's another version where there's the N in that case is
and
number of molecules,
yeah.
and there's the Boltzmann constant times temperature. So
Oh,
I did give you guys this version as well, right?
yeah, yeah.
Yeah, so you can do either or, but you would then use these numbers, either this one or this one, to figure out the what the mass is.
Okay.
All right. Do you have a question?
Oh, there's. Oh, okay, some of those. Mister, so I in 24 degree, I found it's approximately 3002 pascals.
Yeah.
Okay, so PV equals.
All right. So while you work on that, you want to mute your mic, and I'll.
Oh, okay, sure.
All right, you have a question? Your mic's not working.
How about now?
Yeah. Yeah, that's working.
Um, I was just wondering. I sent you an email earlier today, but I did not realize I was going to be traveling tomorrow. And I may be like in the car during the test time, so I was wondering if I could scoot it to either like tonight or Thursday night, or like a little bit later on Wednesday.
How much later would be a little bit later? Just curious.
Um, because you were gonna open it from 6:15 to 8:15 to start, right?
Yeah, pretty much.
Um, just like an hour or two more. I think I'm supposed to get like done driving at like 5 p.m., which is gonna be 8 o'clock ish Eastern.
All right. Will
So
you be? Will Do you want to do it then?
um I'd be fine starting at like soon after 8 Eastern, like 9 Eastern. I'd be perfectly comfortable starting then.
All right, I'll do that.
Is that all right?
Yeah. Uh,
Okay.
I didn't respond only because I wanted to. I was going to respond, but unfortunately wasn't. I did not have access to um, I shouldn't say I didn't have access to email, but I didn't have access to sit down and have the time
No
to
worries.
send the email.
No
So
worries.
I was actually going to do that after this.
That's I'm okay with this result. So I'll try and start it before 9 Eastern.
Okay,
Thank you.
no problem.
Appreciate it. Can I also
Anytime.
ask what was the average on the last test?
The average. The average before the curve was a 58.
Before the curve?
Mm-hmm.
Is the grade we see a curved grade?
Yes.
Oh, interesting. Okay. What was the average after the curve?
It basically got curved to a 70, 71-ish.
Okay. I didn't
Yeah.
realize we were seeing the post curve grades. I thought that was like raw scores.
Well, what ended up happening on the first test was because a lot of people did really well,
Right.
there wasn't really a curve. It was
Mm,
mainly the only curve that really was there were for the people who uh,
did
failed
poorly.
below 50
Yeah.
because the way my curve works is I curve you to a 50. Like that's the lowest grade you can get, short of just not doing it or cheating, in which case you get a 0.
Yeah.
Um, so those were really the only people that were getting curves, were the people that were getting either a 50 or 55. They were kind
Okay.
of curved up to there. But anyone who got higher than, I think it was like 65, there was absolutely no curve. In fact, um, some people were actually supposed to be curved down, but I kind of avoided that.
Yeah.
Um, but this one, it wasn't as what? How should I put it? This one had a much bigger spread, so people were being curved, up to their score.
Okay. So an uncurved 58 was the average, and that got curved to like a 70-ish.
Hmm.
Okay. All right. Sounds good. Thank you. Have a
No
good day.
problem. You too. Bye.
Mr. Cloud.
Yeah. What's up?
Um, uh, I think I'm a little confused of how to find the n value.
The n value?
Yeah, if I'm using the PV equals nkt.
Okay. So yeah, you found the number of molecules.
Wait a minute. Let me see. Hmm. Uh, okay. Never mind. Give me some time. Let me find the molecule.
Well, I mean, you could find the number of molecules or the number of moles. But what you would do is, yeah. So like, because the thing is, you now have the pressure. It was about like 3,000, right?
Yeah.
You know what the volume is because they gave you dimensions. You know what R is because that's a constant, and we know what the temperature is. It's the 24
Degree.
Celsius, so we have to convert that to Kelvin.
Yeah.
So all we have to do is essentially plug and chug. Oh, right. You said KT, right? So if you're
Mm,
using KT, then K is also a constant. Uh, the only
yeah.
thing you'll have to worry about is how to find the mass. And I was going to say that comes into play with using the known molar mass, essentially, or molecular mass.
Okay. So molecular mass. If I don't, it's gonna be 18 grams per mole, right?
Yeah, well, so if you have if you have the molar mass, then you might want to actually um, use the NRT instead of the NKT, since uh, that mass is used with moles, so you'd want to actually solve for moles. I mean, you can
Uh,
find the molecules and then convert, or
so around 87.53 moles.
That still seems really high. Oh, I forgot to actually mention. I was so focused on getting the mass, I forgot about it. If you actually look, it says it's got a relative humidity of 65%,
Uh,
meaning the pressure is 65% of that.
oh,
Remember that? Yeah, that pressure is supposed to be like the maximum.
so 3002 is the maximum, and I have to use 3002 times 0.65.
62, 65, yeah. You could just do it to the moles that you got. Like you just take the 87 that you got and just do 65% of that.
So it's gonna be around 56.9. It's around 1.02 kilogram.
Say that one more time.
It's around 1.024.
Yeah. Yeah, that's fine.
Okay. Let me see if there's another. Okay, so can we look at number 21?
21, okay.
So for the answer of part B and part C, there are two pretty close values, but not exactly the same. Like for part B, the temperature is 241 something, and part C, the temperature is 243 something in Kelvin. Uh, so I'm not sure. And by the end of C, is asking me whether temperature in part B and part C are consistent or not. So not I'm not sure. Should I write not consistent?
Well,
Because
what are the numbers again? Well, what'd you get for part B?
yeah, so part B I got around 241 kelvins, and C I got 243.58 kelvins.
One thing I would remind you is that a lot of these numbers are approximations. So, um, and it says that it kind of mimics it. So, uh, in this case, it's important to note that being slightly off isn't bad. You know, we don't really expect it to get the exact same number. One thing that you could do is you could check to see if it's within 10% of each other. Uh, so you can take the difference. So you said the first one was 240 what again?
One,
241.
241.
And the other one was 243-ish.
Yeah,
All right.
I mean,
Well, you said it was like point six or something. So I'm gonna round that to 244.
yeah,
So that's
but
about a difference of three.
yeah, but that's not even 1%
Yeah.
compared to the.
So the while it may seem like that these numbers aren't consistent, in the grand scheme of it, of how big the numbers that we're working with, and the fact that we actually don't know the exact number of molecules that are moving at each speed, and because of the size of the numbers that we're working with,
Yeah,
uh, it's not that noticeable of a difference. It's actually one of the reasons why when you like in an experiment in like lab experiments and lab settings, uh, you kind of have to fight that urge to think that numbers that are, 10 or so points apart, like that's a big difference. When in reality, if the number is big, ten points might mean nothing. So it's more about a percentage difference rather than like the number difference.
Um.
Does that make sense?
Yeah.
Yeah, so what I would say is because the second number, your part C answer, was within 1% of what we expect, then that's pretty close. In
Okay.
fact, I would say that it's really close.
So as long as it's not more than 10% difference, it's gonna be consistent.
Yeah, that's usually my go-to for a lot of like I said, experimental comparisons that, anything below 10% is like fairly good. Like even if it was 8% difference, that's still not that bad. Granted, not ideal.
Okay, I think that's my questions right now.
Okay.
Yeah. Anyway, thank you for your helping.
No problem.
Okay, bye, Mr. Klaus. See you.
See you later.
See you later.